In this video, which is the 10th in my series on how to write a 3D space shooter game in Unity, we implement radar for our heads-up display in our fighter. The radar allows us to see the position of enemy ships relative to our ship, even when they're outside our field of view. This allows us to get back on target when we're chasing them through space. So grab your favorite beverage, pull up a chair, and follow along as I teach you how to write a 3D space shooter game in Unity. So adding radar, what we're going to do is we're going to take advantage of this built-in display that's on the escort fighter. So if we expand this out, go into the cockpit interior, interior details, cockpit equipment's HUD, there's this cockpit equipment's HUD 2, which is this screen right here. We're going to plot blips on this to represent the position of enemy ships relative to our own ship. And it's going to be a 2D plane, so we're going to show them whether they're to the left of us or the right of us, or whether they're in front of us or behind us. And to represent whether they're above us or below us, what I'm going to do is I'm going to rotate this whole thing forward 45 degrees, and I'm going to display a line below the blip if they're above us, and a line above the blip if they're below us. And that'll tell us whether we need to pitch up or down to get on level with them. I'm also going to scale this display up. If we go into our cockpit camera and solo it, that's not a really huge display. Now this will be bigger in play mode because right now I've got the scene view and the game view open side by side. So it will be a little bit bigger and easier to see. But I do want to make it a little bit bigger than what it was. In fact, I'm going to triple it. I can always play with this later, of course. Yeah, so that's a pretty big screen. I'm going to lower it down a little bit because it's kind of obscuring the view out the window. So that's probably too, I'm making it too big because I'm covering up the joystick handle now, and I'm covering up part of the window. So I think I'm going to sacrifice a little bit of visibility on the screen, on the radar, for the sake of being able to see out the window and not cover up our joystick. I want to bring it down a little bit more. I wish I could keep this view soloed while I'm dragging down the radar. Okay, I think I can live with that. So now we need a visual element to display on the radar screen. So let me minimize this. And I'm going to create a 3D object and call it a sphere. And we're going to call this RadarBlip. And we're going to want to add to this, let's see, we're not going to want a collider. We're going to want to add to this a material. So let's go into our materials folder. I see there's a cockpits folder. Cockpit equipments. Let's create a new material. And I'm going to call this RadarBlip. And we'll make it red. And we'll make it emit a red light. Okay. I think that looks pretty good. So let's go back into our RadarBlip game object, our sphere, and let's drag that RadarBlip material onto it. Okay, and we're going to want to scale this sphere way down. And if we were to, let's create a prefab for that before we do anything else. Under Ship Systems, I'll drag this in here. Now I'm going to drag this in as a child of this HUD. And let me reset its position, scale it back down to 0.005, 0.005, 0.005. And I'm going to want it to be negative 0.01 on the z-axis just to make sure it's above this screen. So you can see there's the blip on the screen. Very nice. Okay, so the next thing we're going to want to do is we want to draw a line above it or below it if the target is below or above the ship. So let me go ahead and apply that. Let's go ahead and delete this here. Go into our prefab. And we're going to want to add a child object. Call this line above. And we're going to want to give this a cylinder. All right, and we're going to give that the same material that we did the blip. Oh, one thing I want to do, under lighting, we don't want to cast shadows or receive shadows, so we can get rid of that. And we definitely don't want the capsule collider. Let's go back into our sphere, under lighting, turn off cast shadows and receive shadows. Okay. Now we're going to want this to be skinny, but tall. And we're going to want it, since it's 5 units tall and we're coming out the middle of the sphere, we're going to make its Y position 5.5. All right. And then we will duplicate this and call it line below. And we're going to want to make this negative 5.5. And we're going to want to rotate it. Which way do I want to, which axis? It's not that one. It's that one. Yeah, so we're going to want to rotate this 180 degrees. So it's growing out of the bottom. That's because we're going to adjust its height based on how far the target is above or below us. And so, did I do that the wrong way? Actually, we're going to adjust this guy's size. Yeah, there we go. We're going to adjust its size accordingly. So it's going to be some percentage of 1 based on how far the target is above or below us. And so I want it to come out that end. And then the line above is going to come out the top. All right, so I think that's good enough for our prefab here. We're going to need to create a script for it. Actually, we're going to want to create a script for the radar screen. So we're going to need a couple of different scripts. We'll start with the easy one, the RadarBlip. Let's go into our scripts folder, ship systems, and we will create a C# script and call it RadarBlip. Double click to open that up in the editor. And get rid of all this boilerplate. This will be a very simple script. All we're going to have in here is a couple of serialized fields for our line above and line below. Maybe if I could type what I'm actually saying. All right, line above, line below. And then I'm going to have a couple of public properties. Line above, expression body method, returning line above. Line below, expression body method, returning line below. We'll go ahead back into the Unity editor and we will add that script to our prefab for the RadarBlip. And we will assign, let's go ahead and open this prefab up. We will assign line above and line below. All right, nice. So let's go into our scripts folder, ship systems. We will create a C# script and call it RadarScreen. And we will double click that to open it up in the editor. And this is going to be one of the more complicated scripts we've written in this tutorial. I'll leave those there for now because I think I need to add them back. All right, so we're going to need a lot of serialized fields, not a lot, but quite a few serialized fields. First of all, we want a game object for our blip prefab. We're going to want a serialized field for a layer mask. So if you recall, we put everything on their own layers. So if we go look at our enemy fighter, you'll see he's on the enemy layer. And so what we're going to do is we're going to actually use something called Physics.OverlapSphere. It's kind of like a raycast, but it's basically going to go out and look around us in a radius, in a sphere, and it's going to look for any colliders that are on a specified layer using that layer mask. We need to have a way to tell it how far to scan. So I'm going to give it a range from 100 to 5,000 maybe. We'll call this, make it a float. We'll call this a radar range. And we'll give it a default value of, I don't know, 500, just to start with. Let's create a serialized field for the maximum number of targets to put on the radar. And the reason I'm doing this is because we're going to pre-allocate an array of colliders that we're going to use a non-allocating version of the Physics.OverlapSphere, so we're not creating garbage. So we're going to pass it in the array to populate, and we want to pre-populate that with a maximum number of targets. Okay, so our serialized field for refresh delay. So basically, we're going to do this in a coroutine. We're going to build our list of targets in a coroutine, and I don't want to be doing this every frame because it might get a little expensive doing that overlapping sphere over and over and over again. So this will basically tell it every quarter of a second, refresh our target list. We're also going to want a reference to our radar screen. And we want to get a reference to the player. Now I'm going to create a bunch of private variables here. I'm going to cache our transform, which if you've been watching me for any amount of time, you know that's something I really like to do for performance. And we're going to want to cache our wait for seconds. So I mentioned we're going to be using a coroutine. And if you allocate wait for seconds, every time you do that, you're creating garbage. So I'm going to just cache that so we're not creating garbage in the middle of our coroutine. We're fostering some puppies. I'm sure you can probably hear them yapping in the background. So all these variables I'm creating here, they're going to be used for calculating where to put the blips. And I'm putting them out here so that instead of just declaring them locally within the scope of where we're doing the calculations, one, because we'll be doing this in a loop and I don't want to be pushing things on the stack and popping them off or creating garbage by creating things on the heap over and over again. And also, in case there's anything wrong, if I'm not seeing the results I'm expecting, I can go into the debug mode on my inspector and see the values for these variables in the inspector and see what we're doing under the covers. So I'm going to want a radar transform. and renderer. We're going to cache the renderer for the radar. And we're doing that so we can get the bounds and see how big it is, and know then where to put our blips so they stay on the radar screen in the right position. Some vector 3s for our calculations. Target position, I'll just initialize that to vector 3.0. Blip position, I will initialize that to vector 3.0. We want our local direction. And again, these are all variables that I will be using in my calculations. And these names should be kind of telegraphing what I'm going to be doing. Now this array that I'm creating here for the layer names, we're passing in a layer mask, and that's a bitwise OR value of the different numeric layers that we're going to be adding. Because we might want to display more than one thing on our radar. We might want to show enemy ships, enemy projectiles. We could even show asteroids. I mean, we could put all kinds of things. We're going to pass in a mask. We're going to assign that in the inspector. I'm going to have a method. I'm going to be trying to find the root collider, the root node for the item that we collide it with. It's easier for me to show you than try to explain it to you in words. If we go into the editor and we look at our fighter here, the way the object sphere overlap works, the overlap sphere works, is it's looking for a collider within a radius on a particular layer. So if we're looking on the enemy layer, it's going to look for colliders within our scan radius. But the fighter does not have a collider. So if we expand this, I mean, you can look at it, there's no collider here. But some of these individual components do have colliders, and they're all on the enemy layer because they're all children of that enemy fighter, and I assign them all to the enemy layer. So my overlap sphere is going to return all of these colliders. But what we really want is this. So what I'm going to do is I'm going to have a method that will take that collider and it will roll up the tree, up the parent hierarchy, to find the transform that is my parent, the highest parent that's on that layer. So all of that to say, I need to split the string value of my layer mask into an array of strings. Because I need to see if the layer names contains the layer of the object that I'm getting as I'm rolling up through that hierarchy. That'll make more sense when we actually write the code. Hopefully I didn't confuse you too much with that explanation. And speaking of an array of colliders, here's our array of target colliders. This is what's going to get populated by that Physics.OverlapSphere. I want to initialize a bunch of this stuff in the awake method. First of all, just for sanity, I want to make sure if I haven't assigned a radar screen prefab, I want to just return. Let's see, wait for seconds will equal a new wait for seconds refresh delay. So caching that. Layer names, if layer mask is not equal to null. Actually, layer mask is an integer. It will never be null. All right, so layer mask will be, or layer names will be layer mask toString split separated by commas. So if you look at the string value of this layer mask, like in the debugger, it will be like enemy, comma, enemy projectile, comma, whatever. And it's comma delimited. So this will give me an array, splitting that up into an array of strings. And our target colliders will equal a new collider array. And I want to initialize it to be our max target. And actually, I don't want to put that in here. I want to create a function called onValidate. This is another callback that Unity provides. And this way, if I change it in the editor, I'll come in here and I'll reallocate my target colliders. In fact, I want all this to be an onValidate. But I do want to initialize some stuff in awake. I do want to check to make sure we're not dereferencing a null value. That's what I get for saying null while I'm typing. All right, so targets and range, that is a list. We want to go ahead and allocate that. Targets and range, new list transform. All right. Radar transform is going to be the transform off of the radar screen. The radar renderer will be radar screen, get component, renderer. And we're going to cache our own transform. All right, so we want to do some things in start. We want to, again, not do anything if we haven't assigned a radar screen. I probably should check some of the other variables too, but we'll just get an error in the console if we try to dereference something. We want to get the bounds of our radar renderer. That needs to be an assignment. Actually, I probably should just check the radar renderer here. All right, so I get the bounds of that, and then the radar width will be the bounds .size.x. Radar height will be the bounds .size.y. That's all we need to do in start. And the reason that we're doing this, is because we want to position the blips within the bounds of the radar screen. So we need to adjust their position by the size of the actual visible area of that screen. All right, on enable, we want to start our coroutine. And we're going to call it refresh target list. And that will be an enumerator refresh target list. Yield, return, wait for seconds. And on disable, we want to stop that coroutine. Okay, so we're going to actually do the drawing of the radar blips in late update after everything's had time to calculate. And I'm going to put that below here. So void draw target blips. All right, so what do we want to do in this coroutine? I'm going to have a variable called size, and this is going to be set, I'll initialize it to 0. It's going to be set by the Physics.OverlapSphere. And I'm actually using a version of that method that does not allocate a collection. We're going to pass in the array that we want it to populate. Let's see, we want to transform for our individual targets. I'm going to declare it out here so we're not declaring it over and over again inside our loop. So we're going to say while true, this coroutine will loop forever until it is stopped. And at the end of the routine, we'll do the yield because we want to refresh our target list first, then delay. So we want to do that immediately. So targets in range, first thing we're going to do is clear that. And we're going to make our call to the Physics.OverlapSphereNonAlloc. We're going to pass in our transform position. We're going to pass in our radar range. We're going to pass in our target colliders. And we're going to pass in our layer mask. And that's going to return the number of colliders that we hit within this radius for this layer mask. And we're going to iterate through that list. And we're going to set our target to be, we're going to create a new method called getRouteTransform. And I'm just going to pass in I. And let's go ahead and create method. So what is getRouteTargetTransform going to do? So basically, this is where we're going to take the transform for the collider at this position in this array of target colliders, and we're just going to roll up the hierarchy until we find the parent for this layer. All right, let me actually move this down below where we draw. And transform root will equal target colliders at position I, and I will return that unless, let's see, while root.parent, so while we have a parent, and this is kind of a complicated function. So we have that array I created of layer names, and I want to see if it contains this guy's layer, the parent's layer. And the way I'm going to do that is I'm going to say layer mask, layer to name, and I'm going to get that from the parent's game objects layer. Oops. So while we have a parent and that parent is inside of this layer that we're looking for, we'll assign that to our root. Okay, I need to figure out what this is complaining about. Makes sense. All right, so I take the transform off that collider based on the position that we're looking for. As long as this guy has a parent that's on our layer, we want to use that parent until we get to either there's no parent or we get to a parent that's not on our layer. And that might happen if I add object pooling down the road, in which case our enemy ship will live underneath a don't destroy unload node, or if I just have my enemy ship spawner spawn them under some node. I just want to make sure that the root object I'm getting is actually the enemy ship that I want. All right. So refresh target list will get the root transform. And then what do we want to do with that root transform? We want to, if our target's in range doesn't contain that target, then I want to add it. And that should not happen. This logic here should prevent that from happening. But I just want to make sure that I don't have any duplicates in my list of targets. All right, so now that we have our list of targets, we need to draw our list of targets onto the radar screen. So first I will clear the display, so that's going to be another new function. And what I'm going to do is I'm going to get rid of all the children on our radar transform. Remember, we cached our radar transform in awake. And what we're going to do is say while the child count is greater than 0. So our radar screen has some child blips. We're going to get the child at the first position, get the first child. All right. And then we are going to set its parent to null and destroy it. So that will clear our display. All right. Now I'm going to declare a variable here and call it scale. We're going to use that later when we set the size of our lines that go above and below the blip. Okay, so we want to loop through all our targets. So for each target in our targets in range, we want to calculate the normalized position of the target. I'll say calculate normalized target position. And I'm going to pass in the target position. I'm going to create that method. So this is basically going to say that our normalized or target position is going to equal the target position that was passed in minus our player's position. And I want to divide that whole thing by the radar range. Just looking over that, I think that's all correct. I could actually just make that a line in here instead of calling an extra method. In fact, I think I'm going to do that. Sometimes I try to get a little bit too clever. It's just that I like to be explicit. And I like my names to be very indicative of what the code is doing. So by saying calculate normalized target position, that makes it really clear that I'm normalizing this position. But I don't know, I don't think it's that hard to understand. All right, so now I want to calculate the blip position for that target. And this is going to be another function. So let's call this vector3 calculate blip position. Actually, is blip position, did I make that a global variable? I did, so that doesn't need to be returned. Calculate blip position. All right, so that's going to take our target position, which again is a global variable. Pretty much everything I need is global, or they're member variables. All right, so we're going to calculate our angle to target. We're going to take the target position dot x, target position dot z. We're going to convert that from radians to degrees. And then we're going to calculate our local direction using quaternion.inverse. We're going to take our player's rotation and we're going to multiply that by basically the direction toward the target. So we're going to take our target position, subtract the player position. So this is basically getting our local direction and takes into account our rotation. And then we want to calculate whether or not the target is above us or below us. And we'll use this to determine whether to show the line above, line below. We'll use that local direction and we'll subtract 90 degrees from it. And make that an assignment. All right, now we will calculate our player angle by taking our Euler angles on the y-axis. I keep forgetting to use the equal sign. And the radar angle, we'll take our angle to target that we calculated up there and subtract our player angle minus 90 degrees, because this, again, Unity is a left-handed coordinate system and you got to flip everything around 90 degrees. All right, we're going to calculate the normalized distance, which is just the magnitude of our target position. And we're going to convert all this to radians because we're going to be using cosine and sine on our angle to determine the x and y position of the blip. So angle radians equals radar angle times, radians to, or I'm sorry, degrees to radians. All right, calculate the blip x position. That would be our normalized distance times the cosine of our angle in radians. And blip y will be our normalized distance times the sine of our angle in radians. And then we will actually put this now on our blip position vector. So it will be blip x times the radar width times 0.25. So basically a quarter of the size of the screen, because it could be on any quadrant of the screen, and each quadrant is basically a quarter of the size. So blip position dot y will be blip y times radar width times 0.25. And we want to set our z position just to be a little forward of the screen. All right, so there is our blip position. So we want to draw that blip. We're not really drawing. That's kind of a misnomer. What we're actually doing is we're going to instantiate a prefab for our radar blip at that position. So first of all, our blip is instantiate blip prefab, and we want to instantiate it as a child of the radar transform. And then sometimes when you instantiate something as a child, it will change the scale. So we're going to get our transform from our blip and set its local scale to be the same as our prefabs. And we want to set its position, it's actually its local position, to be our blip position. And again, all these things are member variables outside of this function because I want to be able to look at this stuff in the inspector to see what kind of values we're getting for these in case things are not rendering correctly. Normally I would not do that. Okay, what else do I want to do here? I want to handle drawing the lines above and below. I'm thinking I put this stuff in the wrong function. Yeah, we want to call our calculate blip function, our blip position here. Yeah, and then this needs to go down here. I was really confused for a second. All right, so after I do that, I want to check to see if we need to draw those lines above and below. And again, we're not really drawing anything. We're just turning lines on and off and then setting their size. So we're basically saying if our pitch is not pretty much 0. If it is pretty much 0, let's just get the heck out of here. And I might extract this out into another method, but for now, let me just go ahead and get it in here. We need to get the RadarBlip component off of our blip. And then we need to set its line above active if the pitch is less than 0. And we want to activate its line below if it's greater than 0. That will turn them on and off. Now we need to set their size. So if pitch is less than 0, then we will say that scale, which is a variable we declared up here, so it's not being pushed and popped off the stack every iteration of this loop. So we will say scale equals RadarBlip, line below, transform local scale, and then we want to adjust the Y value of that scale. We want to clamp it, and the value we're calculating is going to be the absolute value of pitch divided by 90. So if you imagine, if we're facing straight forward, our pitch is going to be pretty much 0, but if we pitch upward, that pitch is going to get plus or negative, but once we're straight up or straight down, we don't want to go any higher than that or lower than that in terms of how long we want to draw this line. So we're going to divide this by 90, and then the minimum value will be 0 and the maximum will be 1. In fact, I'm going to go ahead and, well, I was thinking for efficiency I'm going to calculate this exact same value twice, which seems kind of silly, but I'll leave it there for now. RadarBlip.line above .transform.local scale equals our adjusted scale. And then we will return. If pitch is greater than 0, then we're going to do the same thing, but we're going to do it for line below. Actually, so if pitch is less than 0, then I want this to be, I think I wanted this to be line above. Yes, line above. It doesn't really matter because they should have the same scale. But what it matters is what I'm assigning here. All right, I think this is what I want. Okay, that was a lot of little, not super complicated code, but more than we usually do in this tutorial. Let's go into the Unity editor, and we're going to give this a test. First of all, let's look at our escort fighter. We need to add a radar script, a radar screen to him. We need to add our blip prefab. We need to set our layer mask to enemy. Range is 500, that's good. Max target is 10, that's good. This is good. We need to add our radar screen and then our player. I think that should do it. Cross your fingers. Zoom into the cockpit, and I see a blip on my screen. And that line looks to be working. but he's not, the position of the blip is not moving. Only that line is moving. So something isn't quite right there. Okay, so to debug this, I'm just going to jump into my RadarScreen script. I'm going to go ahead and get rid of these unused using statements. I notice it thinks I'm not referencing radar height, so we should be referencing that up. Left off the knot there. Okay, so I suspect the issues, though, are around where we calculate the blip position. Now, one thing I notice, I need to add a -1 here because I want it to flip the way it works on the y-axis. Well, you'll see it when I test this again. So let's go ahead and jump back into the Unity editor and give this a test. And we should see our little blip move left and right, and he is. All right, up and down, backwards and forwards. Now, I do have a bug in here. If I was to rotate all the way around and then go left, you see the blip was going the wrong direction on the screen. And that's a real simple fix. I just wanted to save that for afterwards to show you how to fix that. Down here where we're calculating our blip position, what we want to do is we want to say if our local Euler angles.z is greater than 270. Is that right? No, if it's less than 270 and it's greater than 90, meaning we're flipped over. Let's go ahead and use the float there. Then we want to take our blip's x position and flip it. .z. Now, Ryder is going to suggest something really good too. Let me go ahead and make this greater than or equal and go ahead and wrap it in braces. There's a syntax that I only recently became aware of. Watch what Ryder does. It's going to say merge into pattern. So now it's saying if my local angles.z is less than 270 and greater than 90, I think that's really cool. Let's jump back into the editor and we will hit play. And if everything is working, we should have a working radar. So he's above me, he's below me, he's to my right, he's to my left. I'm going to rotate all around. He's to my right, he's to my left. It is all working. Now I'll just blow him up. I mean, I have to, right? I need to add sound effects for the lasers and the engines. We do have that explosion sound effect. All right, so we have working radar. So I actually do have a couple of bugs I need to work out before we call this done. I wanted to test what would happen if I copied these enemies. So we had more than one. So we'll put him above us and to the left. And then we'll put this one below us and to the right. And what you're going to see is all three of them positioned at the exact same place on our radar screen, kind of overlapping each other. It's actually, it might only be showing one of them, but it's not showing the other two. So the bug is actually two bugs. First of all, this max targets needs to be a lot higher than 10 because this is limiting the number of collisions that the overlap sphere call will find. And if you remember, just the one ship had 10 of these. So I'm going to go ahead and make this something like 200. And then the big bug is down here in our get root transform. It turns out that layer to name, well, it turns out that toString for the layer mask does not give us what I thought it gave me. And so we can actually get rid of this whole layer names thing. We're going to go up here and delete that. And then where we reinstantiated it, we're going to get rid of that. We don't need it. It's a lot simpler than that. All I need to do is save off the layer from our root. And then as we're traversing up our hierarchy, I just need to say layer equals parent.root.parent.layer, or GameObject.layer. So yeah, that will, as we go up the hierarchy, make sure that we're finding the thing that has the same layer that we have. Much simpler, a lot less confusing. I don't know why I didn't think of that the first time. I tend to overcomplicate things sometimes. Now I hope that will fix the issue. That should limit us to just the one item from our hierarchy, but it should find all 3 ships. I have not tested this, so this is a live test. I will hit play. Zoom into the cockpit. And darn, I'm only seeing the one blip. Oh, because the way Rider works with Unity, even though I changed it in the script, I have an overridden value in the inspector. So I need to set that in the inspector. And there we go. I've got 3 of them. And they should all drop out of range. It's interesting. Looked like he was out off the radar for a while. I might need to increase my refresh rate. But that's working. Okay, so we've got radar. Did I just lose him again? I have to keep an eye on that to see if there's something glitchy going on there. Okay, I'm going to increase my radar range to 1,000 or thereabouts. And I'm going to take these guys and turn on their AI ship movement. The problem is they're all going to go after the same target. Oh well. Well, no, that's right. They all have the random script on them. There aren't. Well, yeah, but the target is moving randomly, and they're all going after the same target. So, it's still fun. Ooh, I hit them. They're hard to hit. I need to get those missiles working. come on. I got to destroy the last one. There we go. All right, I'm very, very happy. We got radar working. One thing I wanted to look at, I wanted to test this. I want to test the interpolate. I want to test it on my ship too. I just want to see if it makes the movement any smoother, or if it totally hoses it up. That looks pretty good. Okay. All right. So we got radar working, and that interpolation seems to still not mess up the movement, and it should smooth out and remove any jitteriness that we were having from the AI ship movement and even from the player-controlled movement. Well, that wraps it up for this video. We got the radar up and working. We're able to follow our enemy ships even when they go off screen. As long as they're within radar range, we can get back on target, follow them, chase them, and blow them up. It's starting to feel like a game. So I have a lot of ideas of what I'd like to do in the next video. One thing I could do is work on the enemy AI and get them not just pursuing the player, but actually shooting at the player. Start working on a little bit of a state machine there for the enemy game logic. Another idea would be to add some seeking missiles. That would require us to have some way to lock on to an enemy target. That would be pretty cool to start working on a targeting system. I want to work on getting the asteroid field looking more organic. Instead of one big spherical asteroid field, we could have several broader overlapping fields, and that could cover a lot more space too. But anyway, I want to hear what you want. Drop a comment and let me know, what do you want to see in the next video? What do you want me to focus on? And if you have any questions about what I've done or any suggestions, again, drop a comment and I'll do my best to get back to them as soon as I can. And I'll definitely take your suggestions into consideration for the next video. I also have a Discord channel, and I'll be posting a link to that down in the description. There's not much activity on it, but it could be a place if you want to have a discussion either with me or with anyone else about the kind of things that I'm posting on my channel. That's another place you could go. So do me a favor and click the like and subscribe button. It really does help me to grow my channel. It helps with the analytics. And I want to get this content in front of as many people as possible, and it really does help me out. So thanks again for watching. I really do hope my videos are helpful. And enjoy the rest of your day, and good luck on your game development journey.